Have you ever wondered how a computer knows exactly what to do? The answer is program structure. Program structure is the organized way that instructions are arranged and executed to solve a problem. Think of it like following a recipe. You need to complete each step in the correct order to get the desired result. Every program is built using three important programming constructs: sequence, selection, and iteration. These constructs guide the computer from the start through the execution of instructions and finally to a successful solution. Understanding program structure is the foundation of becoming a good programmer because it helps you write clear, logical, and efficient programs. Every computer program is built using three core programming constructs. The first is sequence. Sequence means instructions are executed one after another in the correct order. For example, a program might first ask for your name, then process the input, and finally display a greeting. The second construct is selection. Selection allows a program to make decisions based on conditions. For example, if your exam mark is 50 or above, the program displays pass, otherwise it displays fail. The third construct is iteration. Iteration means repeating a set of instructions until a condition is met or for a fixed number of times. For example, displaying the numbers from 1 to 10 uses iteration. Together, sequence, selection, and iteration form the building blocks of every program you will write, whether it's in Python, Java, or C#. Now, let's look at the first programming construct, sequence. Sequence means executing instructions one after another in the correct order. Each step is completed before moving to the next step. For example, a program may first take input from the user, process or add the values, and then print the result. If these steps happen in the correct order, the program produces the expected output. Sequence is the simplest and most fundamental programming construct, and every program uses it. Why is sequence so important? Computers follow instructions exactly as they are written. If the instructions are arranged in the wrong order, the program may fail or produce incorrect results. For example, imagine trying to display a calculation before performing the calculation. The result would be incorrect or unavailable. On the left, you can see an example of instructions that are out of order, leading to failure. On the right, the instructions are arranged in the correct order, allowing the program to execute successfully and produce the correct result. This is why programmers must carefully organize every instruction so the computer can perform tasks accurately and efficiently.
Every simple computer program follows a basic sequence of 3 steps: input, process, and output. First comes input. This is where the program receives data from the user, such as typing a name, entering numbers, or clicking a button. Next is process. During this stage, the computer performs calculations, comparisons, or other operations using the input data. Finally, the program produces an output. The output is the result displayed to the user, such as a message, a calculation, or a chart. So the basic flow of a simple program is always input, process, output. Understanding this sequence is essential because almost every program you write follows this logical pattern. The second programming construct is selection. Selection allows a program to make decisions based on conditions. The program checks whether a condition is true or false and then chooses the appropriate path to follow. For example, if a student's mark is 50 or above, the program displays pass. Otherwise, it displays fail. This means the program can produce different outputs depending on the input it receives. Selection is commonly implemented using statements such as if else, or switch, depending on the programming language. Without selection, every program would follow only one path and could never respond differently to different situations. Selection makes programs smarter, more flexible, and capable of making decisions just like we do in everyday life.
To make decisions in a program, we use selection statements. The most common selection statement is the if statement. An if statement checks whether a condition is true. If the condition is true, the program executes the instructions inside the if block. If the condition is false, those instructions are skipped. Another widely used statement is the if ... else statement. Here, the program checks the condition and chooses between two possible actions. If the condition is true, it executes one block of code. Otherwise, it executes the else block. These conditional statements form the foundation of decision-making in programming and are supported by almost every programming language, including Python, Java, and C#. Let's see how an if-else statement works. The program begins by checking a condition. If the condition is true, it follows the true path and executes block A. If the condition is false, it follows the false path and executes block B instead. Notice that only one path is executed during each decision. The program never runs both blocks at the same time. For example, if a user's password is correct, the program grants access. Otherwise, it displays an invalid password message. The if/else statement allows programs to react differently depending on the situation, making applications more intelligent, interactive, and useful.